I'm Nathaniel, and today we will now do question 3 of step 2021. For this question, you will need knowledge of the two functions in the question, the floor function and the fractional function, as the mathematical world calls it. And you also need how to, well, solve simultaneous equations, because that's what the topic's going to talk about. But there's also one more thing which I need to talk about, which is modular arithmetic. Why do we need modular arithmetic? We'll see later when we need to solve part 3. So modular arithmetic is a version of arithmetic where instead of all the integers on the line, they literally wrap up. So in modular arithmetic part 12, which is clock arithmetic, the 12 becomes 0, or is, in math speak, it's congruent to 0. Now, we are now going to use modular arithmetic mod 1 in part 3. Now you might be thinking, well, modular arithmetic mod 1's pointless because you only have 0. Well, it has a point. In fact, an infinite number of points. That's great. I just made a joke out of modular arithmetic mod 1. Anyways, so modular arithmetic mod 1 is just all the real numbers between 0 and 1, but 1 wraps up to 0. So it's any real number between 0 and 1. Get it? Great, so let's solve part 1. So let's number these equations, part 1 and part 2. From equation 1, we can deduce that floor x equals to 4 and fractional y equals to 0.9. And from equation 2, we can conclude that fractional part of x equals to 0.6 and floor of y equals to negative 2. Because you add these two up, you get negative 1.4. So this means if we add it up, y equals to negative 1.1 and x equals to 4.6. Now let's clear this up for a while and just think about what we had just done. So the same techniques we are going to use are going to be used for the solving of the next few questions, which involve what in math speak we call them cyclic permutations. And you see how cyclic permutations come in very, very handy for solving part 2. Well, so in part 2, given the x, y, z satisfy these simultaneous equations, show that this fractional y plus floor z equals to 3.2 and solve those equations. Well, how do we do that? Well, it's very simple. First, let's label the equations 1, 2, and 3. So what we had done here is that we are trying to remove x. And as we see in the question, floor x plus fractional x equals to x. So we had to do a clever manipulation, 2 plus 3 minus 1. Now it just doesn't seem so clever anymore. Now it seems quite common. So y plus fractional y minus floor y plus floor z plus z minus fractional z equals to 6.4. So since y minus the floor y is fractional y, we can happily write 2 fractional y. And since z minus fractional z equals to floor z, 2 floor z equals to 6.4. And then fractional y plus floor z equals to 3.2. There, we have just solved the first part of the question. Now there are actually 3 parts to part 2. The other being the other cyclic permutations. So we are now going to remove y. How do we remove y? We had to do 1 plus 3 minus 2 based on the same logic. And so since we have 1 plus 3 minus 2, x minus fractional x being floor x, so 2 floor x. And since 1 plus 3 minus 2, you get z minus floor z equals to fractional z. And then we get 2 fractional z being 3.6. And so floor x plus fractional z equals to 1.8. And after that, then we are going to eliminate z. So we have to do 1 plus 2 minus 3. So yep, that's right, 1 plus 2 minus 3 in that case. So we do x minus floor x equals to bracket of x, fractional x, so 2 fractional x plus 2 floor y equals to, well, it is 4.2. The answer to the life, the universe, and everything divided by 10. So fractional x plus floor y equals to 2.1. So now we have gathered enough information, x, y, z. So floor, so we need the fractional parts and the floor parts. So x floor x is 1 and fractional z is 0.8, and fractional part of y is 0.2, floor z is 3, floor x is fractional x is 0.1, and y equals to 2. Great. So this means x equals to 1.1, y equals to 2.2, z equals to 3.8. Aha! Now we go to part 3, the most intriguing part of our whole adventure. First, we saw these simultaneous equations. How do we do that? We actually substitute 2y instead of y. But there's a twist. They should have written the fractional part of 2 fractional part of y. Why? Because this will be let's say this is equal to 0.2, right? So this means 2 fractional y could be 0.2 or 1.2. See what I did there? This is modular arithmetic at work. We do this type of thing when you're studying trigonometry, when you had to get the answers from 0 to 4 pi, when you want to get the answers from 0 to 2 pi, when there's a 2 in your equation. Well, this is the exact same type of situation. So the fractional part of y could be 0.1 or 0.6. And the first solution, when y equals to 0.1, follows immediately. X equals to 1.1, y equals to 1.1, and z equals to 3.8. Now, what about the solution where is fractional y is 0.6? Well, x will still be 1.1, y will be now 1.6. And just to satisfy the equations, since we added 0.5 to fractional to y, we must delete 1 from z or subtract 1 from z, because x plus fractional x plus 2y plus floor z equals to 5.3, and floor x plus 2 fractional y plus z equals to 5, following the equations, because if we go calculate, so floor x, well, actually let's just use the equation with floor y. So 2 fractional y plus floor z equals to 3.2. when this is 1.2, floor z becomes, well, 2. And floor y doesn't change, therefore the value of x doesn't change. Now, since when floor z equals to 2, z will now become 2.8. Because the fractional part of z doesn't change, but we just changed the value of the coefficient of y, now everything has changed. Well, that's it. I hope you enjoyed this little video, and I see you in another step video.